So these ideas, these Islamic ideas or published Greek ideas about sun-centered universes finally reached Western Europe in the 1400s. And that was coming at a time of a reawakening and the end of the Middle Ages, and an increased emphasis on education and on publishing. And it's represented here by this artwork that shows the celestial sphere and somebody peeking out beyond it to see the rest of the universe. So this was the rise of the Enlightenment and new ideas and new ways of looking at scientific models, and the rise of the scientific revolution and the dawn of the scientific method. So for the rest of this, we're going to look at Copernicus and Brahe and Galileo and Kepler and Newton. So let's get started on Copernicus. This came at a time, Copernicus was in the 1400s, coming at a time when the Middle Ages were ending and people were distrusting religion. And they were seeing that religion didn't have all the answers, and that man could be naturally good. Man didn't have to be relegated to hell. This was the rise of Lutheranism, and rebellion against the Catholic Church. So it was an environment where you could take risks. You could look for different explanations. The source of this movement was actually the Italian Renaissance, which started first and was really powerfully impacted by the Ottoman Empire all around it, the Islamic schooling all around it, and also by the navigational problems. Remember, problems produce progress in scientific method, of long sea voyages and of exploration. There were many problems in getting around the Mediterranean and in getting around the North Atlantic and getting around to the New World. And there were better scientific instruments that were being developed all the time. This time, between up to the 1400s, was known for the great spread of the Ottoman Empire. Look at it here in green. It moves all the way from Asia, all the way through Africa. At one point, the Ottoman Empire had taken over Spain. And in looking at this breadth, you can see that the Ottoman Empire borders on Russia and Poland and Austria. So there was a lot of give and take amongst the schools that were in those regions as well. And in fact, Copernicus was a Pole, actually a Prussian, in the late 1400s into the 1500s, who adapted this mathematical point of view in his astronomy. And he knew that Ptolemy's epicycles were just so clumsy and so messy that he started reading and researching that problem by reading the Islamic texts of Aristarchus. And in doing so, he thought Aristarchus really had the right answer, that the sun is at the center of the universe. And in fact, he started to develop his own model based on Aristarchus's writings and the translations. And his scientific model, based on his hypothesis, was that the sun was at the center and there were planets between the sun and the earth, and planets beyond the Earth, all in circular orbits. He took his hypothesis and his model, and he developed mathematical data that used the geometry that Aristarchus had been using and took it a bit farther. In his analysis, he was able to calculate planetary orbital periods, the amount of time it took for the orbit of Mercury, of Venus, of Jupiter, of Saturn, of the Earth, and their relative distances to the Sun. Nobody had done this before. And in doing those orbital periods and the relative distance to the Sun this time, he concluded that Aristarchus was right. This was a sun-centric universe. And it was simple as that, at that. He liked it because the simplicity of saying that the sun was at the center of the universe meant that he could explain the changing pattern of Mars's movement with respect to the stars. He could explain the differences in Mars's brightness, the differences in Mars's size, and its speed and its retrograde motion by putting the sun at the center. He could understand that the Earth had an orbital period that was shorter, and Mars had an orbital period that was longer, so that the Earth could catch up to Mars. It seems like Mars is ahead, and Mars is ahead, and Mars is ahead, but then the Earth catches up, and suddenly Mars is behind, and Mars is behind. He could understand that the Earth could lapse Mars. It made sense. It was simple and elegant. It's still a little tricky. And the reason it's tricky is because Copernicus still used circles, because he was still addicted to the old philosophy of Plato and Aristotle that circles were perfect. So while he did put the sun at the center of the circle, he didn't like Ptolemy's off-center thing. The sun at the center. By using circles for the orbit, his calculations were going to be off base. He recognized that his calculations were off base and still put in smaller epicycles to counteract that movement that he couldn't predict well. But it was a sun-based model, and heliocentered means sun-centered, from the Greek word for sun, helio. In fact, that sun-based method was one that Copernicus did not feel confident in publicizing. And there were two reasons for that. One, he did not want to get burned at the stake for going against the church. And two, he knew that his model didn't predict accurately. He didn't know why, but he knew that the predictions weren't coming out right. Like I said, the circles threw off the planetary motion. So he saw the draft of his first edition of his work published literally on the day that he died, because he didn't want to be burned at the stake. So he waited until he was 70 to publish, and then he died the day he saw his first edition. But this Copernican revolution in scientific thought was that the Earth is just another planet. It rotates, it revolves around the sun, just like a lot of other planets that he noticed. Kind of like that Neil deGrasse Tyson video that we looked at initially, where you might think that your ego is blown up and the Earth revolves around you, but you got another thing coming. This was the revolution that Copernicus was bringing to the world, that the Earth is just like any other planet. And it was a scientific awakening that undermined religion. at a time of enlightenment and new ideas. See you on the other side.